Dear students, in today's session we are going to talk about other properties of colloids. What are they? The first one we are going to learn about coagulation. I think you are familiar with the word called as coagulation, otherwise it is called as a flocculation, becoming bigger in size. And coagulation is the property of colloids, and we can prevent it. And what are the methods of preparing the colloids we have learned, and what are the means by which we can prevent coagulation we are going to learn today. So coagulation depends on addition of electrolyte. The main person who is responsible for coagulation is electrolyte. When we are adding an electrolyte, you know boys what is meant by electrolyte? Electrolyte is a combination or a solution of NaCl salt. It gives Na plus and Cl minus. There, since these electrolytes are charged species, they go and disturb the stability of the colloidal particles. They will make them bigger and bigger. At one moment the colloid will come and settle at the bottom. It will flocculate. So electrolyte addition. So what way, if you want to coagulate a colloidal solution, the electrolyte's nature is determining the process. Aluminium 3 plus ion is having a greater capacity to precipitate than barium 2 plus ion. This again having greater capacity to precipitate than Na plus ion. I think from the logic I have given them, you can understand more the positive charge over the cation, the flocculation capacity will be more. And you may be asking a question, sir, why to coagulate the colloid? And coagulation sometimes very useful for us. You know, during the rainy season, you can see the water's color is a little brownish yellow in color, and the water is a turbid water. The same manner we can't drink the water. And the local department, they will treat the water with alum. Before distribution for domestic usage, they will treat it with alum. Alum comprises of aluminium ions. That will precipitate all the unwanted dissolved solids, clay particle and other impurities, and the pure water is supplied for the public. So for that, the coagulation is also important. And are they talking only about cations? No, they are going to talk about anions also. So we have FeCN6 3 minus. This is a complex anion, and there you can see the minus charge is 3 minus available. Similarly, you have SO4 2 minus and you have a Cl minus ion. And the precipitation or coagulation power of this ferricyanide ion is more comparatively because of the greater negative charge available. So the coagulation depends on addition of electrolyte. So we have to talk about this factor. And there is a 3-mark question they may ask you, flocculation value. That means the minimum amount of electrolyte should be added will make the precipitation or coagulation possible. Usually they will add in millimoles per liter. And 2 hours time they will calculate. Okay, so that is a 2-mark question, you can note it. And the second factor which is influencing the coagulation, just now we learned, is electrophoresis. You know what is meant by electrophoresis. In electrophoresis, a colloidal solution charge can be identified, and the negatively charged salt particles will move towards positive electrode, that is anode, and positively charged solid particles will move towards the cathode. This we have experienced in electrophoresis, and during the time the charge gets discharged, thereby the aggregation of particles are possible. So electrophoresis is also one of the reasons for the coagulation of colloidal particle. Then the next one is by mixing of oppositely charged colloid. Okay, so suppose one of the colloidal solution is negatively charged, and we are adding purposely another colloidal solution which is positively charged, then both of them mutually they will coagulate because of the mixing of oppositely charged colloid. So mutual coagulation will result in the sedimentation of the colloidal solution. And then the last one we have to talk about the process of boiling. What is boiling? As I told you, any colloidal solution is carrying two combination. One is the dispersed phase, and the water molecules or the solvent molecule is a dispersion medium. And when we are boiling, it is a very clear understanding. When you boil, the dispersion medium, that is the solvent, will slowly evaporate. Thereby the quantity of dispersion medium available will get reduced, and the molecules will have more collision, that is solid particles will have more collision because of boiling and obtaining the heat energy. During the time they will join together and precipitate. So these are the factors which are influencing coagulation of a particular colloidal solution. Last topic in the discussion of properties of colloids is protective action. What is protective action? We have two types of colloids we learned in the introductory classes. One is a lyophilic type of colloid, the other one is a lyophobic type of colloid. For example, if you add gum in water, it is lyophilic. That means the gum and the solvent, that is water, will have more attraction. That means they have more strong bonding between them. So the colloid will be very stable. But if you prepare gold powder in water, colloidal gold, that may not have more affinity for the dispersion medium. In that case, what happens? After some time it will get precipitated. So gold colloid is very important for the intramuscular injections. So we need to prepare that in colloidal formation. So how to do that? So they talk about protective action. That means it is applicable mainly for lyophobic type of colloids. Maybe we can take the example of same gold. I am trying to prepare gold, colloidal gold. Okay, gold in water. During the time, maybe 10 ml of gold solution we are preparing, and in that there is a presence of 1 ml of 10% NaCl, sodium chloride, is an electrolyte. Because of the presence of electrolyte, this hydrophobic gold colloid will come down and settle as precipitate because of the coagulation behavior. We want to protect them. For protecting this, we are seeking the help of a lyophilic type of colloid. Maybe we can take gelatin. Gelatin in water, you add a little. So maybe I am taking 0.005% of gelatin and adding in milligrams of gelatin. So this gelatin addition will start stabilizing the presence of gold in the colloidal form. So they call this as a gold number. Maybe a 2-mark question important. Gold number. So gold number is nothing but addition of a certain milligrams of this biophilic colloid to stop the process of coagulation of 10 ml of gold by adding 1 ml of 10% NaCl available in that solution. So this can be a 2-mark or a 3-mark question. The next discussion is going to be about emulsions. Have you heard this term emulsions? Yes. Even in your home, for the painting of walls, we talk about paints and emulsion paints. Yes. Emulsions. What are emulsions? Emulsions are colloidal solutions, but they are made up of liquid and liquid type. Well, we learned in the types of colloids. Both the dispersed phase and the dispersion medium, both of them, if they are in liquid phase, then we talk about the emulsions. So emulsions, easily mixing nature is possible, and sometimes they don't mix. The reason is they are further classified into 2 types. One is oil and water type of emulsion, and another one is water and oil type of emulsion. With one example you can understand better. Milk is one of the examples for the oil and water type of emulsion. Butter is an example for water and oil type of emulsion. In milk, if you closely observe, the major portion is going to be water only. Almost 84 to 86% is water only, and the fat and oily substance available is only little. So milk, oil portion is less, water portion is more. Same way you take butter and try to boil the butter or heat the butter and convert into the process of ghee making process, you can see at a particular temperature you will get a cracking noise coming out of this butter. The reason is the present water molecules by getting the heat energy will evaporate very fast. So oil is more, water is less. That is butter. Now the classification of emulsions we have learned. The next thing is sometimes if you try in a normal means, you take a vessel carrying water. In that water you add a spoonful of oil. So it's a simple method of preparing oil in water type of emulsion. Is it possible? So easy like the way I explained? It is very difficult process. You try it at home. For some time, even if you stir a little, for some time the oil will get dissolved in water, and it will be available in the form of droplets, and after a few minutes you can see the oil will form a thick layer on the top and water will get separated. You can't mix them easily. Then how to do that process of mixing? They use a term called as emulsification process. That means converting an immiscible condition of 2 liquids into miscible form. So we require a mediator. Who is that mediator? Most probably a lyophilic salt can be used. In this case you can use a little of a soap solution, because soap has one side of the soap molecule is oily in nature, one side of the soap molecule is aqueous in nature, that is water in nature, water soluble in nature. So the soap will behave like a mediator. Add a solution or a shampoo solution, the process of mixing is possible. So that process is emulsification, and the material you added, the third material you added, is called as a emulsifier. And this is about emulsions. Next thing we have to talk about how to test whether a particular emulsion is a water soluble emulsion or a oil soluble emulsion. The next content we have to talk about how to identify the type of emulsion given to us. Might be, as I told you, there are two types of emulsions available. One is the oil and water type, other one is the water and oil type. And next method we have to identify them. Identification of a type of emulsion is our next step. So what are the procedures we are following? If oil in water type of emulsion, the major proportion is water. So this particular emulsion will be soluble in aqueous medium. Water and oil type, oil is more, so this will be soluble in oil phase, that is organic phase. The first step they take to identify the type of emulsion is dye test. In dye test, they apply a oil soluble dye. A dye may be an organic dye which is oil soluble, that is applied to a particular emulsion, and they will start shaking it. If the aqueous medium is more, that is oil in water type of dye, oil in water type of emulsion, this dye will not impart the color easily, because oil portion is less, water portion is more, there will be a repulsion. In case the same thing is added here, because oil is more, then the oil soluble dye will easily dissolve here, it will impart the color there. So thereby we can easily identify whether the particular emulsion is oil in water type or water in oil type. This is one of the methods. Next method is viscosity test. As you know, the viscosity test will give us whether the particular emulsion is oil portion is more or water portion is more. The oil-rich particular emulsion, the viscous nature will be more. From that we can easily identify the nature. The next one, they will go for spread. So spreading test. Usually an oil emulsion will spread uniformly. So that gives us an identification. Spread test is a good test for identifying a type of emulsion. Whereas the aqueous type of emulsion will do the spreading very, very slowly. This is one of the tests. And the next test is conductivity test. What is conductivity test? Conductivity of the particular emulsion, you know, aqueous medium easily will conduct electricity. So from that you will identify if some of the emulsion given to us is conducting electricity very fast. It's a clear indication that it is an aqueous emulsion. So these are the methods we will identify the type of emulsion.
What is an emulsifier really? Well, it's nice to know this, as you find emulsifiers in many of the foods we eat, such as bread, biscuits, cakes, margarine, mayonnaise, dressing, and ice cream. Well, let's first look at the word itself, emulsifier. An emulsifying agent is something that is capable of creating an emulsion. And making an emulsion means to mix two liquids that are not themselves capable of binding to each other. You might recognize the expression, to pour oil upon the waters. And you've probably noticed that oil and vinegar won't mix together at all when you make a dressing. But when you stir, you emulsify to mix the two liquids, or rather, to create an emulsion. However, it's on borrowed time because before long, they will go their separate ways again. This is where the emulsifier comes in. An emulsifier is an ingredient that ensures that water and oil can be mixed together so that the fluids remain evenly distributed in each other. More technically, emulsifiers consist of molecules of a water-loving nature and a fat-loving nature. In this way, the emulsifier acts as a binding agent between the fat and water, in that the molecule will bind both together. But where do we really see an emulsifier being used? Well, for example, in margarine, which is a mixture of fat and water. Without an emulsifier, the water would lie on the outside of the fat. Yuck! And that's not exactly what we want from a margarine. The same is true of ice cream. Here, we can thank emulsifiers for the fact that you can make low-fat ice cream, which tastes great and is nice and creamy to eat. Without emulsifiers, the small air bubbles would disappear and the ice cream would shrink and probably not be particularly nice. And in bread, emulsifiers improve.
We learned about emulsion and how to prepare and what is the job of an emulsifier, that is stabilizing the emulsion. We are going to talk about the next process of DEEMULSIFICAtion. That means separating the dispersed phase and dispersion medium into two phases. And that process, as I told you, emulsion is a combination of two layers. That is a dispersed phase, the colloidal particles, and the dispersion medium. Now the process of separating these two we call it as a DEEMULSIFICAtion process. How do they do it? First method, they will heat it and they call it as a distillation process. While distillation process, if you are supplying more amount of heat from the bottom, then the dispersion medium will absorb the heat energy and evaporate. Thereby the concentration of dispersion medium will be reduced and the emulsion will break. And the next process, by adding an electrolyte. Electrolyte job, as I told you, electrolyte job will go and disturb the charges of the colloidal particle. So thereby the electrolyte influence on colloidal dispersed phase will make them to be separated. That is the next one. By chemical means, by adding a chemical, they will disturb the emulsifier. I told you emulsifier job is to make both dispersed phase and dispersion medium to be intact. They will disturb it by chemical reaction and do the process. Otherwise, you can go for a process of freezing. If you cool it, chill it, one of the medium or dispersed phase can be easily converted into frozen and can be removed. Just for example, in your milk, I told you major proportion is water only. If you deep freeze it, first the water molecule will become ice and that can be removed. That is one of the process. Otherwise, by applying centrifugal force. Centrifugal force means they use a device attached to the motor with the centrifugation process, and when you keep on rotating due to centrifugal force, the solvent and dispersed phase will get separated. This is one of the method. And the next method is they will go for ultrasonic waves. Ultrasonic waves will be passed and disturb the combination of both. Or else they will heat the medium with a high pressure, heat it in the presence of high pressure and break it. So these are the ways we can de-emulsify an emulsion. One we have to talk about is inversion of phase. Sometimes what happens, an oil in water type of emulsion can be converted into water in oil type of emulsion. How do they do it? By applying an lyophilic type of salt, this is possible, or they may go for addition of soap. So converting one form of emulsion they use an agent, and now a lot of research is onto this process. So the inversion of phases in a particular emulsion, and water and oil type to oil and water type, and oil and water type to water and oil type. So in near future, a lot of inventions will happen in this, and that is the inversion of phase is the last one about the properties of emulsion. There are many fields colloids are useful for us. The colloid which is running inside your body, yes, I mean to say the blood is the biggest wonder of God, and it takes all the required nutrients for the nourishment of body, and also it carries oxygen from the lungs to all parts of the body, again carries carbon dioxide to the lungs for exhalation process, and it is purely made up of a colloidal dimension. And a lot of food items we are using, so we can classify this way. Colloids are useful in the food industry. Most of the food items we eat every day, they are made up of a colloidal dimension. Be it your food preparation at home, rice porridge, or all the juices you take, and ice cream, halwa, or if you take most of the milk products and ghee, everything is made up of a colloidal dimension. And how colloids are useful in medicine is the biggest area. From your childhood, your medicines are prepared in the form of tonics and suppletive. Do you know the reason? Just now I told you, your blood is a colloid, and when you take your medicines in the form of tonic or in colloidal form, they go easily mix with the blood and can be transported to all parts of the body. And in that line you can think of milk of magnesia, that is used for stomach disorder, or colloidal calcium or colloidal gold for injections they use it. And if you take Adgerol, that is colloid of silver, along with the gelatin, they add it in the eye lotions. Sometimes when you get eye infections, they supply this Adgerol. Colloidal antimony is used for Calazar. So all these are given in the form of colloidal medicines, so that the body can easily take them. And the antibiotic drugs they supplied are also in colloidal form. Okay. How do these colloids are used in the industry? And industrially, the colloids find a lot of usages. Be it the purification of water. In water purification, colloid chemistry is used, and as I told you, the presence of alum will precipitate all the clay particles which are dispersing, and then the water can be used for the purified supply for the human beings. And the process of washing, what is even at home or big industries it is used. Most often the soaps we use, they are capable of removing the dirt and the grease. For example, when we are playing, most often this area in the collar region get easily wetted with the water and oil. Over the oil, the dust particles will go and stay. And if you normally wash it with water, it won't go. We use a soap. Soap has, as I told you, it has both ends. One end is water soluble, other end is oil soluble. It will remove the grease and dirt and then get dissolved in the water and can be removed. So this is one of the process of soap action, that is colloidal chemistry.
The cleansing action of soaps is based upon its tendency to undergo micelle formation. The stearate ions of soap arrange themselves around an oil droplet in such a way that the hydrophobic part of the stearate ions is directed towards the oil and the hydrophilic part projects outside. The hydrophilic part, being polar, interacts with the water molecules, and the oil droplet is pulled away from the cloth into the water to form an ionic missile. The stearate ions of soap molecules help in making a stable emulsion of oil with water, which is later washed away with the excess of water. A sheath of negative charge is formed around the globules, which prevents them from coming together and forming aggregates. We can also say that soap
leather tanning, the process of tanning. What is a leather tanning process? And hides are nothing but the skin from the bigger animals. We talk about the leather, converting the skin of the animal into leather. They go for a process of a tanning process. So in the tanning process, unwanted impurities will be removed. The protein fibers in the skin of the animal will be loosened. In between the gaps, they'll go for adding this chromium salts or tannin liquid. Nowadays they go for even vegetable substitutes. And by that process, easily decayable the skin of an animal can be converted into a leather. Afterwards, the leather won't be putrefying. That can be used for various other.
Going to clean our hide with Proviera probiotics for leather. This solution helps getting rid of the salt, blood, dirt, hair, and top part of the skin, while opening up the collagen structure as well. This is not an easy rub, as millions of 100% natural helpers have to work day and night to clean the hide completely. Afterwards, our hide needs some altering to look its best. That looks great. Next stop, splitting. Here the hide is divided into the grain layer, used for full grain leather and nubuck articles, and the split layer used for skin suede and split hide leathers. This lime splitting is mostly done to create thinner and more flexible leather. Sometimes, and depending on the article, we would have to split the leather again at a later stage of the leather making process. Now we have to get it ready for tanning. By using a tanning system like Stahl Easy White Tan, we are able to use less salt, water, and energy. That's not only...
We have rubber industries. So in the rubber industries, we talk about latex. See, latex is a type of negative type colloid, and you can see the Nagarcoil and the regions around Kerala, they have rubber trees, and they add acetic acid or formic acid and convert it into rubber latex to rubber preparation. The way there we talk about colloidal chemistry. When we talk about PVC, again we talk about colloidal chemistry. And disposal or treating of sewage water. So sewage water comes from different households and it is highly contaminated water, and that water cannot be let into the river bodies. We have to purify them and recycle them. For this, we are going for again colloidal chemistry. All the wastewater, after first layer of filtration is over, they pass an electrical energy, and the charge of the colloids are lost. They will sediment down, and all the sedimented particles can be reconverted into manure, and they supply for the plants, and the water can be recycled. formation of the delta regions. In Tamil Nadu, Tanjore, Mayiladurai, Thiruvarur, all these regions are highly fertile. You know the reason? So river Kaveri starts from Coor and it carries all the good rich minerals and clay particles from different parts of Karnataka and Tamil Nadu. And because the delta regions are closer to the seashore, the soil carries a lot of minerals and electrolyte. It sediments all the good soil, good clay, minerals, nutritious soil into those regions. So this is the main reason for the high fertility of the delta region. So that's why colloidal nature of the clay water, because of the electrolytic influences, it gets precipitated in those soils of the delta region.
Meets the sea. River water is a colloidal solution of sand and clay, which carry a negative charge. Sea water contains a number of electrolytes of sodium, magnesium, and calcium. When river water comes in contact with sea water, the positively charged ions of the electrolytes coagulate the negatively charged colloidal particles.
Electrostatic precipitator. The carbon and other dust particles released in the atmosphere from industries are removed by electrostatic precipitator. In this method, 2 electrodes are fitted against the inside walls of the smokestack. When high voltage is applied, an electric discharge takes place.
Go for electrostatic precipitators. That means you have in all the industries and plant, for example, NLC, Naval Lignite Corporation, they burn the coal and produce a large number of the smoke. All the smoke particles will come out through these chimneys. If all the coal smoke is coming out through the chimneys, it will pollute the atmosphere. And in order to avoid that, the chimneys are fitted with precipitators, that is the positively charged electrode and negatively charged electrode. In between them, a potential difference of around 50,000 volts will be given. When the dust particles or the smoke particles with the charged colloidal nature comes here, the cations will get attached with the cathode, anions will get attached with the anode. Thereby, they will lose their charge and get precipitated as carbon blocks. They can be removed. So the air coming out through the chimneys will be very free. And if you look at the sky is looking blue in color. I told you the reason behind the colloidal chemistry of Tyndall effect. So there also we talk about colloids. And in chemical industries we talk about analytical chemistry. Analytical chemistry. There about when we are discussing about qualitative and quantitative analysis, most of the reagent we add and the color changes in the reaction and precipitation, all that comes under colloidal chemistry. So colloids are everywhere and we learned a lot about colloids. Now I assume that you students will look here after. Chemistry is a very close friend of yours and you try to understand every aspect of life by understanding the chemical reaction taking between them. Thank you.